Origin's Gage study offers a suite of tools. This video will cover the Gage cross-repeatability and reproducibility study, which is a balanced study designed to measure variation from three sources. The measurement device. This is the variation that comes from repeatability. The operator, along with the interaction between parts and operator. This is the variation from reproducibility. And finally, the variation that comes from the different parts used. The first step is to create a Gage worksheet by clicking on Create Gage Worksheet. Enter 10 for number of parts, 3 for number of operators, and 2 for number of replicates. There are 3 randomization options. Do not randomize. Under this option, run order will be the same as standard order. Randomize all runs. Under this option, all runs will be randomized across both parts and operators. Randomize runs within operators. Under this option, operator 1 will be assigned runs 1 to 10 and 31 to 40, operator 2, runs 11 to 20 and 41 to 50, and operator 3, runs 21 to 30 and 51 to 60. Part numbers within these assigned runs will be randomized. Book 1 has the results for options 2 and 3. Double-click the filter cell under Run Order to modify the rule and explore the differences between the two approaches. We will select option 3 for our crossed R&R gauge study. Enter the corresponding measurements under column E. We have already done this in Book 2. Under Input, select Parts as the part numbers, Operators as Operators, and Measurements as Measurement Data. Under Options, select the ANOVA method to calculate the variance components. The second method, X-bar and R, cannot be used to calculate the parts and operator interaction. Select K as 6. When K equals 6 under the normal distribution, approximately 99.7% of data fall within plus or minus 3 standard deviations. Enter process tolerance as 20 and select both upper and lower. Tolerance measures the amount of acceptable variation during production of the parts. Next is the historical standard deviation. We will leave this field as is, and the study parts will be used to estimate process variation. Go to the Plots tab to select the desired plots to be generated for the report. The first plot, measurement plot, is divided into nested sections. First by part, then by operator. The 3 operators took 2 measurements of each part. The lines joining the 2 circles have a positive slope, which means the second measurement is greater than the first measurement. The gray, red, and blue lines for each part are clustered together, but operator 2's measurements are consistently lower and operator 3's measurements are consistently higher. Any deviation from the cluster suggests that at least one operator measures a part differently from the other operators. This is captured as an interaction term between parts and operator. The first table, ANOVA, all terms, shows that parts by operator is not a significant source of variation. In practice, the parts by operator interaction term is rarely significant since most operators will take measurements that are consistent with others. Significance in this term indicates that certain operators require additional training. The second table, ANOVA gauge calculation, displays a table with the interaction term removed. The rightmost column shows a small p-value for part, suggesting that the term is significant. This is also reflected under the measurement plot, where the measurement for each part is different. For part 1, it is about 9 mm, while for part 7, it is about 14.4 mm. The p-value for operator is also small, suggesting that the term is significant. The measurement plot shows that although the measurements are clustered, operator 1's measurements fall between operator 2 and operator 3. This plot is divided by operator and shows the range, which is the difference between the 2 measurements, for each part. All points are within the control limits, which means that each operator shows good repeatability. This plot is also divided by operator. The y-axis is the average measurements for each part. The 3 lines are parallel, suggesting there's no interaction between part and operator. Again, operator 2's measurements are smaller than the other 2 operators, while operator 3's measurements are larger than the others. Scroll down to the parts by operators interaction plot. Again, the lines are parallel, indicating there is no interaction between part and operator. The variance components table measures variation from three sources: measurement device or the repeatability, operator or the reproducibility, and part. Under this table, total gauge R&R equals repeatability plus reproducibility. Reproducibility is equivalent to operators. These two rows are identical. 86.08% of the variation is from the 10 parts. This is ideal since most of the variation should come from the different parts. Next is the gauge table. Standard deviation is the square root of var comp from the previous table. Study var is equal to standard deviation times k. We specified k equals 6 in the input window. Use the %study var column to identify areas where the production process can be improved and reduce measurement variation. The %study var for total gauge R&R is equal to 37.30771%. For a measurement system to be acceptable, industry standards require a value less than 10%. This suggests that the gauge needs calibration. Percent tolerance is the study var divided by tolerance multiplied by 100. We specified a tolerance of 20 in the input window. The percent tolerance for total gauge R&R is 4.37303 divided by 20, multiplied by 100, which equals 21.86514. Number of distinct categories is 3. The gauge precision is low, which suggests difficulty identifying different parts. The industry standard recommends a number greater than 5. The next plot is measurement by part. The green circles are the raw values, and the red hollow circles are the average value for each part. The last plot shows measurement by operators. The plot shows that operator 2's measurements are consistently lower than the other two, while operator 3's measurements are consistently higher than the other two. Ideally, we would like to see a horizontal red line. The final step is to create a Type 3 gauge study. Click on Book 3. Repeat the steps for Book 2. The only change is that the value for operators is left as optional under the input window. Click OK. This creates a Type 3 study. A single operator takes 6 measurements of 10 different parts. The report worksheet only shows 2 sources of variation: the measurement device and the parts. These are the variation from repeatability and the variation from different parts used. Notice that there's no data for any rows displaying reproducibility. The operator measures each part 6 times. With these additional measurements, we can calculate a standard deviation for each part. The R chart has been replaced by an S chart, and sample standard deviation is the y-axis value.